Hello, my name's Mark. I'm here to help you with your GCSE and A-level maths studies. This week's topic is slightly different. We're not concentrating on a topic as a whole. What we're doing is looking back and revising a couple of topics from the AS and A-level maths course. So those students sitting Year 12 and Year 13 of the maths 2-year course. Because we're focusing on topics we've done previously, what we're going to do is be revising from the pure section, and we're going to take one topic from the Year 12s, which is AS, discriminant, and one topic from the Year 13s, which is partial fractions that we've studied previously. We're going to practice an exam style question on both to see how you're getting along. As always, don't be afraid to make mistakes, because that's part of the learning process. It shows you what you need to correct next time. If you're prepared to put in the work and the hours in practicing questions and learning, you will remember how to correct your mistakes as you go throughout the course. So a couple of quick tips to get started. I won't go through the theory again because I've gone through that in my worked examples video. If you want to go back and take a look at that, feel free. But a bit of theory on the discriminant, if you remember. If b squared minus 4ac is the discriminant, then being above 0, it would cause two distinct solutions. May it be a solutions to the intercepting the x-axis or solutions to where two curves intersect. If b squared minus 4ac is equal to 0, that means there's only one solution, and that solution is repeated. If b squared minus 4ac is less than 0, that's where you will not get any solutions, or no real solutions in fact, to any of the problems you're trying to solve. So, let's have a look at this particular question. If it states in this question that 3x minus 2y equals k, where k is a real constant, and you're told that the line L intersects this equation at two distinct points. So what that's saying is you're not finding where the straight line is equal to 0, you're not finding where it hits the x-axis, you're finding the intersection points. So you're being asked to solve simultaneously. Two equations simultaneously is asking where those two curves, or line and a curve in this case, intersect. So you are trying to find the solutions to that problem. So before you even deal with the two distinct points, what you would look at is try to solve the set of simultaneous equations. To do that, you use the substitution method from Year 11 in GCSE. So, what's the best way to do with this? You'd make y the subject in one of the equations, or x, and substitute it in the other. So the easiest way I think to do this would be to write 3x minus 2, and then instead of writing y, you substitute the quadratic curve into the straight line. And what you're left with is 2x squared minus 5 is y. You can do it the other way about if you wanted. You can make y the subject in the straight line and sub that into the quadratic. But it's up to you. You will achieve the same solutions. And that equals k. Then what you would do is multiply out. So 3x minus 4x squared plus 10 equals k. We are trying to find the solutions to this quadratic equation to find the intersection points. So for the quadratic, what we will do is move everything to the right hand side or the left, but I usually like to say make it a positive quadratic if possible, so you're not worrying about if it's a U or N shaped type graph. So I'm going to put 0 equals 4x squared on the right, when you're adding 4x squared to both sides. You're minusing 3x to both sides. You've still got the plus k, but then you've got the minus 10. And then I usually like to put a bracket around my a coefficient, my coefficient in front of x. I'll put a plus in front of that because it's plus minus 3x. And then the entire coefficient of the constant term is k minus 10. Because k is a constant, it's not how many x's there were. If it were kx, then that would be the coefficient of x, but it's not, it's just k minus 10. If we got to this point, we would not be able to solve the quadratic because not all coefficients are known, because k is an unknown constant value. But this is where we go back to the problem, and it states, okay, there are two distinct points where it intersects. So that means when you solve it simultaneously, like we have done, you will get two solutions that are unique, they're not repeated. There'll be two different solutions to this problem. So, two distinct solutions. And we need to remember that means the discriminant, b squared minus 4ac, that's the formula for the discriminant, has to be above 0. If you fill in your b, that is your minus 3, that's the number in front of x, that's your, and then you square that. The number in front of x squared is 4, and the number c is k minus 10. Because whenever you write a quadratic, you write it in ax squared. You just go over that. Okay, that is your a. B is your minus 3. And c is your k minus 10. Right, let's multiply this out to see what results we get. To me, this looks like it won't form a quadratic inequality that you have to solve. But remember, if it's a quadratic inequality, you have to draw the graph in terms of k. And just be careful here, when you are doing the minus 4 times 4, that's minus 16, I would do it in 2 steps. When you multiply out the brackets, just remember, it's minus 16 times both values. It's very easily made a mistake there if you're not alert. Minus 16k, that's absolutely fine, but do not write 16 times minus 10, it's actually minus 16 times minus 10, which is plus 160. And that is greater than 0. If you collect your like terms, minus 16k and plus 169, that needs to be greater than 0. We don't have a quadratic inequality to solve here, so you don't need to worry about drawing the graph for k. You can just rearrange your inequality like it was a linear equation. So you would do, just be careful when you're doing the negative though. I'm going to move it, add 16k to both sides, and then divide by 16. You can do it the other way by taking away the 169, sorry. And then double check if there's any if 169 divided by 16 is in its form, simplified form, which it is. So you can put k is less than 169 over 16. I just want to make a point of, if this equation is solved the other way and you're left with minus 16k is greater than minus 169, and then students go dividing by minus 16, that's absolutely fine. But remember, when you've got an inequality and you're dividing or timesing by a negative number, you have to change the inequality around, okay? Because you are dividing by minus 16, you have to change the inequality, okay, to less than rather than more than. So that's the range of values for k. Just double check at the end of every exam question to check if you've made any mistakes or you've written it exactly like they want you to. It says the range of possible values for k, which you've done. It doesn't specify to leave it in set notation form. So that's how I would leave it. If you rounded answers, put what you've rounded it to. Try not to round early. State what the constant values are and put your units. K is just a constant, so it doesn't have any units here. Alright, so that's a bit of revision on the discriminant. So the next question we're going to look at is a bit more challenging, a bit of revision on the algebra and functions pure course, but it's those that are in year 13 right at the start of their year 2 of the course, and they learn about partial fractions. So let's have a look at this topic. For year 12 students, if you want to get ahead, you can have a look at this, or if you want to wait until the time comes when you're learning about partial fractions, feel free to skip, but it's always best to get a head start on what you're learning in the future. Right, so we're going to look at partial fractions here. This partial fraction is slightly more difficult because the denominator has not been split up into linear factors. X squared minus 4 is the difference of two squares. You could look at it and think it's x plus 2, x minus 2. But they're specifically asking you to show that it's in this form, and they've not factorised the denominator. They've just left it in quotient. If you remember, this is classed as an improper fraction because it's a power 4 over a quadratic. A quartic over a quadratic, what you get is a quadratic quotient. And that's where they've got the ax squared plus bx plus c. It's called the quotient. Right, so the remainder part is the dx plus e. That's the remainder. Now, with these type of questions, what I would always usually suggest you do is use comparing coefficients. It tells you it's in that form. You do not have to use, you can use algebraic division if you want to find the ax squared plus bx plus c and the dx plus e. But I always find algebraic division is sort of the longer version of doing partial fractions. I'm going to do it by comparing coefficients. So how we do that is, as with any partial fractions, you would find the generic form, which luckily enough in this exam question they've told you, ax squared plus bx plus c, and then plus dx plus e. And then you multiply through by the denominator on both sides. So let's say multiply both sides by x squared minus 4. Just note we are given that, so that means we can use this from stage 1. You don't have to show that it's in that form. So if you times through by x squared minus 4, what you get is 3x to the power 4 minus 2x cubed minus 5x squared minus 4. And that is equivalent to, this is where you just need to be alert and ready, because ax squared gets times by x squared minus 4. Right, and then what you get is bx is also times by x squared minus 4. And then you get c gets multiplied by x squared minus 4 also. But just notice when you times dx plus e by x squared minus 4, the x squared minus 4 cancels and you're just left with dx plus e. So that's the type of thing we would look to do at this moment. Now, as mentioned in my worked examples video and the theory behind partial fractions in the A-level course, what you can usually do is break it down into 3 methods. You either have linear factors on the denominator and the numerator is a lesser power, or you can have repeated roots where, yes, you have a linear factor on the denominator, but it appears to be a squared bracket, so it appears more than once. Or in this case, it's an improper fraction, which is a higher order numerator than the denominator. In any of those three cases, I always usually say try and sub an x value in to make the denominator 0. So the x squared minus 4 here, if you make that 0, as mentioned earlier, if you make x squared minus 4 equal to 0, you would get x squared equals 4 and x equals plus or minus 2. So there are two values you can sub in to find A, B, C, D and E, two of those values. So let's try that now. Let's sub in x equals 2 first of all. And when you sub it into all this quartic, you can do it on a calculator, save a bit of time. And I advise to do that in an exam because you're thinking about a few steps ahead and you don't want to make mistakes from mental arithmetic. So 3 times 2 to the power 4 minus 2 times 2 cubed, then minus 5 times 2 squared, and then minus 4, which is 8. The nice thing about subbing in 2, why we've chosen to sub in 2, is because the x squared minus 4 becomes 0. So you don't have to worry about the a part because it gets multiplied by 0. Same thing for b and c. All you need to worry about is dx plus e. So that's 2d plus e. You can't do anything with that equation because there are two unknowns, d and e, and you've only got one equation. So one is dependent on the other. So let's try x equals minus 2 and we'll sub that in. Again, what we will do is the same thing as before on a calculator, and we will do sub in minus 2 and then what we get is this value, 40. So you get 40 equals, or is equivalent to, again, the x squared minus 4 brackets disappear and you're just left with the 2d add e. Sorry, minus 2d add e. And then you've got two equations, one set of simultaneous equations. The easiest way to do these is, yes, you can make either subject and sub one into the other, but they are both linear. So if you add them together, that would eliminate the minus 2d's. You would have 48 is equivalent to 2d minus 2d cancel, and you're left with 2e. And you're left with e equals 24. And circle that to remind yourself that's one of the constants, and to make the examiner's job easier because you're looking for the constant values. If you sub that back into the first equation, you get 8 is equal to 2d plus 24. 2d equals minus 16. And that leaves you with d equals minus 8. You found two of the constants. What you will notice now is we've used the two values, we've used up the values that make the x squared minus 4 equal to 0. So my next suggestion is to use comparing coefficients, and this is the more advanced type of partial fractions. There is another way of subbing x in as 0, that's absolutely fine, but if you sub in x as 0 here, you would get a quicker way to find c. So what I'm going to do is just do one more substituting in of values, and then I'll do the rest of comparing coefficients by comparing coefficients. So let's just show you. If you sub in x equals 0, it works for every single value of x because it's an identity. You're trying to write this fraction in equivalent form. So you're not trying to change the function, you're trying to just change the way it looks. So it works for every single value of x. So 2, minus 2, 0. You could sub in 1 and 3 if you wanted, to get equations for A, B and C. That is another way of doing it. But if you sub in x in as 0, you get minus 4 is equivalent to, and we're subbing it into the first identity right at the very top, after you'd multiply through by the x squared minus 4. And you would get 0a's because it's x squared, so 0 squared times a. Same for b because it's b times 0. And you'd get c times 0 squared minus 4. The d times 0 disappears and you'd get e. Right, so in this particular example you'd have minus 4 is equivalent to minus 4c plus e. Now because we've already found e, you can substitute that value in here. So you've got minus 4 is equal to minus 4c plus 24. And then you could subtract 24 from both sides. You get minus 28 is equal to minus 4c. And then you get c equals positive 7. So for the final two constants, what I'm going to do is do comparing coefficients. So let's have a look to compare coefficients of, and you always choose the highest power. So what I'm going to do is choose the highest power in this on both sides is the 3x to the power 4. So compare coefficients. That just makes it easy on yourself because there's not as many x to the power 4s throughout the equation. So on the left hand side, as we said, we have 3x to the power 4. So the coefficient is just the number 3. On the right hand side, you have to look a bit more carefully and think about multiplying out your brackets if necessary. What we will do is ax squared times x squared would give you power 4s, x to the power 4s, so the coefficient there would be a. Or sorry, lowercase a. Not to mix your capitals and lowercase, usually you use capitals. Alright, the reason why that's it is because if you look at bx times x squared, that would give you x cubed, not x to the power 4s. C times x squared, that would give you x squared, and there's no x to the power 4s remaining. So that's how easy it is to write the value of a. You know a has to be 3, because if these polynomials are identical, which is what the identity symbol means, you have the same amount of x to the power 4s on each side of the identity. Then you can compare coefficients of the next power up, or down if you like. Okay, still use the highest power that you've not used. So let's do x cubed. So let's do the left hand side and the right hand side. So if we look at this identity, what we will see is this time we will have minus 2x cubed on the left. So I'll fill that in here. You have minus 2 on the left hand side, and that equals the number of x cubes on the right hand side. Just be careful to focus in on the a bracket as well to check if there's no x cubes on this bracket, because that would give you ax to the power 4, and then that, when you multiply out, would give you minus 4ax squared. Because obviously if the 4 was 4x and times by an x squared, it would give you x cubes there. So just be aware, checking on each individual bracket. Here would be x cubed, you have b times x cubed, which is fine. Then x's, the c times x squared would only give you x squared. Minus 4 times c would be a constant. dx is x's, and e is just the numerical constant. Right, so the only x cubes on the right hand side are b. So that's how easy it is to find b. So what you've done is found all your constants a, b, c, d and e, And then it didn't actually say express it in partial fractions form. It gave you the general form, and it just asks you to find constants A, B, C, D, and E. So I would suggest you write them all again on your last line of the exam to make it easy for the marker. But I'm going to write it as a whole fraction, well, in simplified fraction form, just to be a perfectionist. And you would write 3x to the power 4 minus 2x cubed minus 5x squared minus 4 is equivalent to, sorry, that's all over x squared minus 4. So that algebraic fraction is equivalent to A, which is 3x squared minus 2x's, because that's your B, plus C is 7. Always remember, if you've not found your constants in A, B, C, D order, just be careful on the order you're writing them down. And then D is adding, well, it's minus 8x's plus 24. So I'm going to write plus 24 minus 8x, because D is the minus 8, so that's the coefficient of x on the numerator, and E is the 24. So you write that over x squared minus 4. And that would be in partial fractions form. It's not probably in simplified partial fractions form, because you could actually have split the x squared minus 4 up into x plus 2x minus 2 and broke that fraction down even further, because 24 minus 8x would then be able to be split up into two constants. But that's not what this exam question required you to do. So they've expressed it in that particular fraction form. So that brings us to the end of that partial fractions question. So what we've covered today is a bit of revision of partial fractions and the discriminant from AS. Hopefully you found that useful. As always, like, subscribe on my YouTube channel if you found the questions we've been through today useful. And as always, if you want to join my members area on my website for extra resources, extra work examples, extra maths revision towards your exams in the summer, you can watch extra videos on my office hours live stream every week that people I like to open. We will go through the Instagram puzzle or example that I put on this week's topic, but the main purpose of it will be to open the chat to as many questions, maths questions, GCSE or A level, that you would like to go through. This can be homework, it can be classwork, it can be maths revision, whatever you feel that you're struggling with it at the moment or want a question answering. I'm here to help, and I'm happy to. Remember, keep on working hard and you will be rewarded at the end of all your exams. Hope to see you soon.